Hello and welcome to today's online session. And I'm Heike, and I want to talk about boundaries of reality today. There are finite aspects in an infinite universe, and I have a very nice mandala for this as well to show you and how to explain, let's say, some of the limitations of the universe. But there are three parts to this whole workshop today. So number one is our perspective. What is our perspective? How do we perceive the universe actually? Yeah, we all perceive it every day, but what are the characteristics of that perception? Then we'll talk about, what are then the limitations, boundaries of reality? How is it actually limited? How is it limited by sound, light, and energy? And I have this amazing mandala here, and we're going to draw it as well. And for this, again, you have to come to our virtual classroom. And in the end, I want to talk about, in a sense, all the scales that exist. And if you keep it very simple, and we're not being scientific here, but rather metaphysical, there are actually just 5. And there's this big hermetic saying, as above, so below. So we'll talk a little bit more about this as well. All right, how do we perceive reality, right? We all have our eyes. This is how we can see. And if you're thinking about geometry, well, look at this eye. Looks like a dot in a circle, doesn't it? Or a circle in a circle. And this is how we perceive. Well, we perceive the reality mainly through our sight. Most people probably take most of it through sight, but then obviously there are also the other senses, which is sight, sound, smell, taste, and then touch. You notice that actually 4 of those senses are just in the head. So we have a lot information coming in from the head that then gets into the brain, and we get this kind of holistic picture of reality. At least what we perceive directly here. And what is that? Well, if you have ever been on the beach or on the mountain or on the fields with not much things around you, and you have a nice view, you will realize when you open your eyes is that actually there's this horizon. And this horizon is like a line. Yeah, it's like a line that separates heaven, like the sky, and the earth, the ground. In this image, I love this image, it's very beautiful because it shows us a very beautiful symmetry. Because everything we're doing is about geometry. And I like this quote. It says, the horizon line reflects the universe as above, so below. So this image shows this sentence quite nicely, but we'll see also a little bit later other aspects that also quite nicely support this quote. But this horizon line, and there's a lot of flat earthers out there, and I'm not going into that topic, but in general, it does give us quite a flat plane and a flat perspective of reality. But in reality, if you come out of that, and a few times in a few other workshops before we're doing this meditation, we're trying to zoom out of our body and just see how does the perspective then change. And all of a sudden, this horizon line is actually a part of a circle. So it's just getting out of that perception on the ground, and you'll see actually the whole thing. And it looks like a circle, even though obviously it's a sphere. Well, approximately a sphere, yeah? In geometry, obviously, the way we perceive reality, nothing is perfectly geometry, but everything is an approximation. And I don't know if you ever thought about this, but if you think about yourself and the way you perceive the universe, actually, it doesn't matter where you are right now on this planet, you are all at the center of your own perception of the universe within the circle of the earth. And that's a big statement, because think about it. No matter how much you perceive, you will always perceive it from a central point of the universe. right, that was a very beautiful journey through the universe, and yeah, just to give us again a perspective, really, where we are on the scales that we know about, yeah, from the Earth, the solar system, the galaxy, to the observable universe, and to the smaller scales, which goes into quantum physics. So I really like this image because, yeah, it really expands our awareness that we really are such a small speck of dust, really. All right, so what we did was we were moving through the different scales, and theoretically, well, this can go on into infinity. And we are actually called into infinity. And the reason is that I want to talk about into infinity a little bit more, because maybe we'll have a very one-directional perspective of it. Most people think, oh, it's bigger and bigger and it goes into infinity, because when we look at the stars, this is what we see. But in geometrical terms, there are different types of infinities. And the other infinity that we saw in the video is actually the infinity going smaller. And in a sense, this is the infinity in. When something is getting smaller and smaller and smaller, we represent that in a dot. And the dot, when we look at it right here, actually doesn't exist because it's a phenomenon, it's a function. It's something that just goes smaller into infinity. And there is no end because that's the nature of infinity. Now, if you ever work with a compass, and we'll be working with the compass or with our virtual compass in a bit, then you will notice that when you use it, you start from this dot and then you open it up. And once you open it up, that is at first division. And that division of that line with the zero in the center, that dot in the center, is actually what we call infinity out, which is happening the same for you. If you stretch out your arms, then actually if you can go infinitely to the left and you can go infinitely to the right. We call this infinity out. In the same sense, what we did here, yeah, we're going into infinity further and further and further. Now, in a circle is very interesting because it's the biggest shape, and we know that because you can make infinite lines within a circle. Yeah, we can make infinite corners in a sense. When you have a square, you don't have that. You only have 4. But in a circle, you have infinite lines that can come across the diameter, in a sense. And that's why there's an infinity inside of the circle. And in the same sense, you can say outside of the circle is an infinity outside, like a tangent in mathematics. So you can have infinite lines on the outside. And mathematically, it shows us that this infinity inside and outside creates actually the circle. And that makes a boundary. And the circle is also interesting because we have even that rotation in the circle. Yeah, let's say when we draw a circle with the compass, yeah, we put it in the center, we open it up, and then we slide the other part around. And this rotation can go on forever. And we have this phenomenon in nature or in the universe. Our planet is rotating in a sense forever. There's no end to it. The solar system is rotating, the galaxy is rotating. So there is that part of infinity going around, which has more to do with time, I'd say. And this is the last part, which I will talk about this more in our future lessons about fractals. You see, this is actually a repeating pattern. Let's say you start with a triangle, then you divide each side into 3, you can make another triangle. You divide the side into 3 again, you can make another triangle. You can divide the side into 3 again, and you can go on into infinity. So you can fill the space more and more, but getting smaller and smaller and smaller into infinity, but never crossing a boundary. That's why this is called infinity in a boundary. Now this workshop is called boundaries, boundaries of reality. There is the possibility of having infinite things within a very defined space, a finite space. And that's, in a philosophical sense, you can interpret this also as well for us. We're living on a planet that, in a sense, yeah, is circular. It's a finite space, yet the things that we can achieve on this planet are infinite. There's an infinite potential within a finite space. Yeah, and all these concepts of infinity, it depends on how we see them, in what context. We maybe have a different perspective of infinity. So that's to infinity. And if you think about yourself, yeah, and I said every one of us actually sits at the center. We all sit at the center of the infinite universe, because it can go into infinity in all directions. And if something expands from your center, and this is what happens with light, because we can only see as far as we can perceive the light, that is the observable universe. It's a circle. And we all sit at the center of that circle. And we all have actually a different perception of that universe as well, because let's say my neighbor is just standing a few meters apart from me. Well, he sees a few meters more of the observable universe in that direction than me. So we all have our unique perception of the universe. So if you made your way to the virtual classroom, which you can find in the link, then you see that there are different tools that we're using, because when we teach stuff, it's very important that you also do something. This is just the way the brain works. Yeah, the more you get into certain things with your full body, the more you remember it. So that's why I suggest for you, if you have a drawing compass, do it on a piece of paper. Or if you don't have one, join me in the virtual classroom and we can draw together. And obviously you can still follow the video by, there's a video pop-up, you can still follow it. Now, here we have this tool with it's actually a hypercube. This is GeoGebra. It's a free tool and it's great to make geometries. And I would like for you to try this, yeah? I'm just clicking on the circle and we're just gonna make a circle. Cool. Yeah, that was easy. So there's our infinity, yeah, infinity in, infinity going out, infinity going around in the infinite circle, and this, in a sense, describes our perception of reality very simply, because really here it's about simplification. Now, once we're here, there's just a few things we can do, actually just one thing. Anywhere on the circumference, we can draw a second circle. Yeah, this is called the Vesica Piscis, and it is going to develop into a mandala called the Eye of God. Now, I put this over this eye on purpose because it's quite interesting that this symbol perfectly, actually, nothing's perfect, but approximately matches the shape of your eye. And not only that, actually, not just the shape of your eye, even the shape, there's a lot of aspects of your face that can be mapped through this very, very simple shape. And here a little bit about philosophy. Yeah, the Vedas, the ancient Indian scriptures, they say that the universe is created and destroyed within the blink of an eye, which means there's this eye, presumably God or consciousness or whatever, that opens the eye and closes the eye, and with that creates and destroys the whole universe. Now, this sounds a little bit absurd, of course, if you think about it right now, because we're here. But on the other hand, actually everything in life comes into existence and then goes out of existence again. I mean, we're all born and we all die. So that's more of looking at it from a grander scale. But actually, if you're looking at quantum physics, and this is what I want to show you a little bit about atoms, this idea of something coming into existence, out of existence, like frames of time, is actually something that is quite, yeah, you can find some proofs for this statement in quantum physics. And yeah, this is just a schematic representation of the atom. The atom is the smallest unit of matter. Yeah, if we think about matter, everything that we can basically touch, it all consists out of atoms. I'm not going to go too much into detail about atoms, but in general, in a very simplistic view, we have a nucleus. And the nucleus here is surrounded by these electrons. So it's like shells, like onion rings. And what's happening is that the atom is actually very, very vibrant. Yeah. So let's say we were talking about how do we see, right? How do we see reality? Now, normally it's like this, that there's the light from the sun and it hits an object, and then this light that hits the object is then obviously reflected, and I receive the light. And the way this reflection actually works is that here's the light waves, and the light waves hit the atom. Now the atoms have these shells, and these shells, these are electrons here. When they receive the light, they blow up, kind of, yeah? They actually jump. And it's like they disappear and then appear in the next shell, like a balloon. That's just an analogy, yeah? So they charge up, basically, and then they release that light again at a certain frequency and jump back. And when this happens, two light waves, because there are two electrons, because they always come into pairs, two light waves will be emitted. Now, if you think about how this looks like, think about water, right? And I take one finger in water, then this finger will create a wave, which is circular. But when we have two fingers, it actually does the same, but these two circles will overlap in this schematic presentation. Now that's very interesting because this image is actually the image that we drew. Two waves that expand to create this image called the Vesica Piscis. And that's actually an interesting thing because this happened in a certain, like in a video, like in a movie, we actually have a lot of frames. Yeah, whenever you see this image right now, it's actually just a lot of pixels that appear and disappear, like a code. On, off, on, off, on, off. And the same actually goes for the whole of reality. Even the sense of touch is all electromagnetic waves that pulsate to create this repulsion of giving you the sense of matter. Which means this analogy of there is this eye of God that's blinking in and out, bringing the whole reality in and out of existence, might be able to be related to this quantum physics effect of energy waves flickering or electrons flickering in and out of existence, yeah? Getting these frame rates and giving us a perception of, this is how reality feels like. And we're actually in this kind of movie, you could say. So the Vesica Piscis plays a very important role in this mechanism, yeah? It actually shows us how these waves look like because they expand equally and they just expand into infinity. But yeah, another thing that is very important is when we're talking about geometry, and I want to go a little bit in this part to the mathematical side. Yeah, and in geometry, and a lot of people also know this circular pattern, it all is about relativity. But in general, you could say whenever we open the compass, and this is the compass right here, then it doesn't matter what is the actual measurement because it's all about scale, because it doesn't matter. Actually, the universe is infinitely big and infinitely small. So it doesn't matter what is actually the size. What matters is whatever that value is, it's a relationship to that value. So we call it, this value, number 1. Could be anything else, but because it's the first distance that we can create, then this is number 1. And here you can see again, yeah, this would be 1. Now the question is then, what is then the distance between, like across the whole thing, if this is 1? For those who cannot see it, that's actually 1, and this is also the same. So the diameter would be 2, and then there's another 1. Well, we got 3. Now 3 is an interesting number. There you go. There's the Vesica Piscis. And this distance over here is number 3, if this is 1. And what's interesting about that the relationship between this and this, we'll see it also in 3. This is actually the length of the square root of 3. So 3 to the square root of 3. Now, this image is today's central topic, and in the mandala called the Eye of God. Here we have a Christian symbol which incorporates actually the central shape, which, yeah, that's why it's called Pisces, because it looks like a fish. And Vesica means bladder, so this is fish's bladder, which actually also looks like a fish, or sometimes also known as an almond shape. Yeah, it's very, very popular in Christianity. And actually, we want to bring a link today also to science, which it's about numbers, yeah, whole numbers and the relationship and ratios of numbers. And it's an interesting coincidence that we have 3 and the square root of 3 over here. Now, I know some people will maybe scream now, but yeah, it's just a quite interesting coincidence that I want to point out here, that actually this distance here is 3 and this distance is the square root of 3. And I want to talk about sound and light because these numbers are actually linked to sound and light. And the thing about sound and light is they're a little bit different, they have different qualities. Yeah, I talked about this image last time, but I want to bring it in here again. So when we say we perceive reality, and that's our one boundary of perception, is actually decide how much can we see. Well, sight in a sense depends on the speed of light. Now, a lot of people think the speed of light is constant, and that in a sense seems to be true, but the true value of the speed of light is still a little bit of a question. Let's say it's very, very close, is that right? 300,000 kilometers per second. So that, in a sense, you could say, if we're just taking off the units, because it's not really about the units, it's about a relationship and a ratio between sound and light. And it's not obvious for a lot of mainstream science and that you learn it like this, but actually, if you look at the theoretical speed of sound in, let's say, the singularity of the Big Bang, which has the most matter, then it reaches the square root of light. That's interesting, yeah? The maximum speed of sound is the square root of light. And I invite you for a discussion later on in our community if you want, because I know that this is a little bit of a difficult topic, but there are actually calculations that show that light and sound have that relationship of the square root, yeah, through the square root of 3 in this case. And what's happening with light and sound is that light over here, it works on a scale, or yeah, you could say if one is very fast, the other one is very slow, because light can travel if there is really, yeah, no matter in the vacuum. And the more matter we have, let's say in air or in water, or let's say metals are very dense, the slower light goes. Actually, it won't travel to matter, because you can close the door and it will be dark. Well, here is about the maximum speed is 3. Then the square root of 3 is the maximum speed of sound in, now it's not in metal and it's not in diamonds, it's about the theoretical speed in infinite dense material. That's the point, in infinite dense material. And that is here around square root of 3, and it will get slower until it goes to 0, because there's a saying that in the vacuum or in space, nobody will hear you scream. And that's in a sense true. So if you have managed to draw this already, maybe even on a piece of paper, even if you haven't and you're just coming in now, open up the compass and draw a small circle, yeah, because we're going to go bigger, and draw another circle on the circumference. Now it's important that we keep the same radius, yeah, there's no reference point to change it, but now we have a reference point to change it. And what we're going to do is we take that reference point here and we draw another circle that has the radius of this maximum speed of sound. I'm just going to call it now this way. The maximum speed of sound. And I'm going to make a second one. We have another Vesica Piscis. Yeah, we have another 2 overlapping circles, but something changed now. Well, obviously, they're bigger, yeah, and it's rotated. Yeah, all of a sudden, we have a rotation from here to there. That's 90 degrees. Yeah, now that is actually the point where we can draw this line here, which is from E to F, the speed of light, if it's 3, yeah, roughly 3. Okay, so we have the speed of light and the speed of sound. Now it's defined on the second stage from these new points over here. And this time we're going to take the radius of the speed of light. We're going to take the radius of the speed of light, which is 3, across, and we can draw another 2 circles. And there we have it. Ta-da! This is actually the eye of God. It's very simple. Yeah, you started with 2 circles. You created another 2 circles. That was 90 degrees. And now we have the third Vesica Piscis, but it comes back to the original orientation. Yeah, so it goes 90 degrees and goes back. And that is a very interesting phenomenon, because it's kind of like an algorithm, because obviously now I could do even more and more circles, and then we can go even bigger, and it goes into infinity bigger. But we'll stop after 3 times, because after 3 times we realize that this Vesica Piscis is actually just a larger version of the smaller one, because it reached the same configuration. And this is very important in terms of algorithms. That even on computers, you're working with algorithms, so it just repeats the code. You don't need to know more, because you know it's going to go into infinity. It will just repeat the code. So obviously, if black, this line over here, is 1, and we said this is 1 when we open the compass, this could be mass, seen here in the famous equation of Einstein, the mass-energy equivalence. Then light is roughly this 3, that's over here. Then energy could be represented over here, because that's actually 9. And that makes total sense, because 1 times 3 squared is 9. So, and what else? Yeah, besides this quite amazing coincidence of energy, light, and sound, and yeah, what else does this image show us in terms of more of a metaphysical map, in terms of our perception? We said already we're here on this horizon line on Earth. Yeah, this is our first step. This is the first Vesica Piscis. Yeah, when we stand on water, there's a reflection. And that's quite a very interesting metaphysical saying, yeah, as above, so below. There is a reflection of what things are happening above and below, just like this image shows us. And I want to show you now the second Vesica Piscis, what it can stand for. Actually, if you look up and you look to the next scale, yeah, and in a sense we have the boundary of the Earth, our atmosphere, and beyond that atmosphere we can look at the stars and the planets, and we see the moon or the sun and some of the planets of our solar system that are all round in nature, circular. And if we're looking below, and this is more in terms of looking below smaller in scale, then if you're thinking about what are you made out of? It's cells. You're made out of cells, and if you put cells in solution, they all are as well circular. Now, obviously, we're talking about approximations and simplification. Cells have different functions and they can look different, but in general, they have a circular form, the nucleus in the sense in the center as well. It all follows similar geometric rules. So we have the solar system above and the cellular realm below, and they both follow, in a sense, roughly circular forms. The next scale up, yeah, we get to the galaxy. Yeah, galaxies, how do we perceive them? That's just like tiny dots. If we're going smaller in scale, then all cells are made out of atoms. You could say the next small units, which all again start with a dot in a circle. But the way we perceive it, and this is actually how we can measure it, is through tiny dots. And the tiny dots will give us an image of how the atom looks like. So what's amazing about this is, so we have this the horizon line, and we said as above, so below. When we're looking at scales, it actually does reflect, in a sense, the way we perceive it. Yeah, and we don't perceive it like that. We cannot see atoms like that. We actually need, we need to shoot them. Yeah, and to see them, we need very particular technologies. And if I just summarize this in a very, very simplistic scheme, and if we start here, and this is Earth. And we see that actually the Earth has this horizon line. And this is actually how we draw perspective if you're an artist. Yeah, the horizon line gives us the boundary of how far we can see. We cannot see beyond the horizon line on Earth. And this is all very flat and has a line as a geometry. If we're looking up to the sky and we see the planets like the sun, well, they're pretty round. If we're looking and here sometimes we're using telescopes, for example. And if you're looking down here into the cellular realm, we're using microscopes, then we also see that roughly the cells have a similar shape, which is round. Beyond that, we're going even bigger. We go to the galactic realm. Well, you need very specific radio wave telescopes to visualize these galaxies. And the same goes for the atom. The way you perceive the atom is also just as tiny dots. And that is just a very simple representation of your perception and the boundaries that go from your center. Yeah, so here you have the horizon line. You look up one step, you see the solar realm. You look down one step, you got the cellular realm. You go one more step up, you got the galaxy, and one more step down, you got the atomic realm. We would say actually there's 5 realms from your perception that you can perceive. Beyond that, it gets very, very fuzzy. Beyond that, it gets very fuzzy. And that simplifies it all very, very much. You know, you have 5 realms that reflect on the horizon line, from the line to the circle to the dot, from the line to the circle to the dot, and that close off, and you can wrap it around in a loop. There is the universe in a nutshell. So we talked about the eye of God, and the eye of God is a map. You could see it as a metaphysical map of the universe, the different scales, yeah, and they're very simple geometries, from a line to the circle to the dot, yeah, 1, 2, 3 from here where you are, and 1, 2, 3 down, and it's actually 1, 2, 3, and it makes the end of this algorithm, yeah, this shape, and it also encodes actually the whole Einstein's mass energy equivalence equation, yeah. Might be a coincidence, but it's quite astounding still to point that out. Yeah, we talked about the perception, your perspective. How do we perceive reality? Well, we said it's through the 5 senses. When we look at the sense of sight, and we talked about today the mandala, the eye of God, yeah, our eyes. The way we perceive light is actually, we see this thing called the horizon, and this is where we sit in. It's a very flat plane from our perception. And we're sitting at the center of the universe, yeah? From your center, we're going into infinity out, yeah, into infinity actually, until we go to the observable universe, and we each have our own perception of that universe. We're all a little bit off. And we can come back to that center, to that point, to that 0 point, and go infinitely small. We also looked at different types of infinity, that actually there can be an infinity within a boundary. Yeah, just like the Earth is a boundary, and technically we can go out, yeah, with some technology, but let's say most of us, we are here, and this is where we live. Just like the cells of your body, they're within the boundary of your body, they don't go outside. In the second part, we talk about the limitations. What are the limitations? Well, there's actually the idea of light, yeah, that our sense of sight comes through light, but it's not just light, it's actually even also touch. It's all electromagnetic fields. And the speed of light is roughly 300,000 kilometers per second. And that ratio of light to sound, yeah, which is another sense of us, can both be represented inside the Vesica Piscis. And also, the Vesica Piscis holds, in a sense, the ratios. Again, it's very important. We're talking about ratios, not units, yeah, just the relationship of the numbers that can make sense with the equation E equals mc squared within the idea of the eye of God. Also, the eye of God, the sense of everything in reality is blinking in and out of existence, like an eye blinking. And that makes sense because even the light that is emitted from the atom happens in this way. The light comes in, the atom blows up, the light is being emitted, and then the next light wave comes. And it's kind of like droplets of information. And these are all happening in the same shape, the Vesica Piscis, because they're all waves. And when waves expand in all directions, well, they make spheres. But these spheres will overlap when this happens at the same time. So they create the Vesica Piscis in that sense, and yet also hold a 90-degree angle, which we saw in this shape as well. We drew the image, yeah, and if you haven't done that, I still invite you to do that. Draw the image, or if you watch it later, the classroom is still open. And just embody the idea of that we're actually staying here on the horizon line. We're looking up to the sky, and we see the sun and the moon, and they're round. And we can look through a microscope, and we see the cells, and if they're in solution, then they're also circular. Beyond that, the next scale is the galaxy, and that's the edge of our perception. Yeah, we don't see more than the galaxies, which are just tiny dots, and that's the edge of our observable universe. And below we see the atoms, which are also just tiny dots. And that just simplifies the whole universe into 5 realms, from the Earth to the solar to the galaxy, 3 up, and from the Earth to the cells to the atom, 3 down. And this makes a total of 5, and 5 is another very, very interesting number in terms of limitations and boundaries of reality, our 5 senses. And it's all wrapped very nicely in the so-called Eye of God. So yeah, that was it. That was the boundaries of reality, and I hope you got a quite good overview of what we were saying, that there are actually these different scales, and the way you perceive the reality is actually quite limited in a sense, 5 senses, but within that light, it just goes as far as the observable universe. Yeah, please join the conversation. We'd like to hear your input. Just give us some feedback, either in the feedback form, in the virtual classroom, or on the link. Or join our Universal and Atomic Geometry group on Facebook, where we can continue this conversation. Other than that, I'd like to thank you all for watching, and I see you hopefully next week. Thank you very much.